write an expression involving the principal angle that represents all angles in the domain. Theta is an element of real numbers that are coterminal with the given angle. All right, so with 285, we're looking for two angles. So two coterminal angles, which means that we have to go 360 minus 285, and 285 plus 360. All right, so what we're looking for here is the coterminal angle. So if I'm at 285 degrees, then we're using this, P plus 360 degrees, or N. So P stands for your principal angle, and right now we don't know what our principal angle is. We just know that we have 285 degrees. So that's one of the angles that we actually, that's the angle we went. So if we think about where 285 degrees is, which direction would we be going to get to 285 degrees? Yeah, counterclockwise, right? So with 285 degrees, we would be starting at 0. And be going in this direction, and it would land in quadrant 4, right? So if we solve for P here, we have to subtract 360.
What is the little n there for?
Pardon me?
What is the little n there for? Where does that come into play?
Oh, yeah, so N, that'll be it. So we'll look at this right now. So N has to be an element of integers. So if for a lot of these, we're given multiple angles. So what if I went the other direction? What if I went P, I don't have enough room here, I'll just go right here. What if I went the opposite direction, right? So with this angle, 285 degrees, I know that I'm going to be ending, not there, it'll be a little further down. It'll be around here that I end, 285 degrees. And that's if I go in this direction. All right, but what if I were to go the opposite direction? This way. I would have to go 285 plus 360 degrees. Now, in this case, my principal angle is a negative number. And remember, if I look up here, the principal angle is always between 0 degrees and 360 degrees.
Holy crap, what happened?
So this is an example where we're actually going to look at the other angle here.
Is your principal angle just 285?
Yeah, so then our actual principal angle would be 285 degrees. Right? So then these are just going to be the angle rotations that we're going. It's 75 degrees.
If the so A, it's a positive degrees. So does that mean that the principal angle is always going to be that? If it's positive.
If A is
Because like 285 is positive, so does that mean the principal angle is going to be 285?
Yeah.
Because it's
Except for
positive.
like 395, it's not going to be.
Yeah.
Because it's over 360.
Exactly.
But if it's
And then
in
negative
between
13 as well because it's below 0.
Yeah.
Yeah.
Okay.
Yeah. So these would not be our principal angles.
No, but if it's in between 0 and 360 and it's
Yeah.
positive, then it will.
And so what we're doing is, and this is where the n comes in, is the second part. So we want to write an expression involving the principal angle that represents all the angles in the domain. Theta is an element of real numbers. that are coterminal with a given angle. And so what we'd have to do is go P plus 360 degrees N, and we go 360 plus 285. But if we do this, we get a larger number, right? So all we got to do is say, so if we do that, we get a larger number. So we don't, in this scenario, we don't even have to do the second formula, but we could just say N is an element of integers. That's all they would be looking for our statement.
Really?
Yeah. All right, let's look at our reference angles. So again, our reference angles, these are things that you've looked at in pre-calculus 11. So a reference angle, this is the acute angle formed between the terminal arm of the rotation angle and the x-axis. All right, so we're not always measuring just to my terminal arm, but I have to measure the acute angle. So what's the definition of acute angle again? Smaller than
90 degrees.
90 degrees. All right, so if I look at this one, is that my reference angle? No, it is not.
Oh, I remember that. This is where you measure from the other one.
Exactly. So I'd have to measure from the opposite direction. So a reference angle, that's the acute angle form, so the angle that's less than 90 degrees. And so this diagram here shows me that I have my rotation angle. So if I start from 0 and go in this direction, this is where the 120 degrees is. All right, so this is 120 degrees. That's my measure of theta. But the reference angle is 60 degrees. So on this diagram, I want to mark the reference angle. Right, so mark 120 degrees on the diagram and 60 degrees on the diagram. So if I were to take my protractor out and measure this line in this direction, that's where this is where my 60 degrees is going to be, right here. But this is my reference angle. Okay? So in each case, sketch the rotation angle and state the reference angle. So I want to find a rotation angle of 243 degrees. So in which quadrant is that rotation angle going to end in?
Third.
My third quadrant, right down here. Because I know that 243 is in between 180 and 270 degrees. So this is going to, down here is where my 243 degrees is. And it's positive. My reference angle, what's that going to be? 60 at 3. Now, in order to find out what your reference angle is, you just take your rotation angle, which is 243 degrees, and you subtract the angle that is nearest on the x-axis. All right, so either 0, you could add to it, or subtract 183 degrees here. And I get a reference angle of 63 degrees. All right, fist of 5, 1, 5. All right, so why don't you guys try next one? Rotation angle of 337 degrees. So rotation angle 337, where's that going to end?
Fourth quadrant.
Fourth quadrant, yeah. So it's going to be down here somewhere. And the reference angle, that's going to be found by subtracting from the closest angle that's on the x-axis. So in this case, it's going to be 360 degrees. Subtract 337 degrees, and we get 23 degrees. So my reference angle is right here, and that is 23 degrees. All right, fist of 5, 1 to 5 there. Okay. All right, good. All right, so this is a good diagram just for kind of organizing what you need to do to find each of your reference angles. So the diagram, it shows the relation between the reference angle and the rotation angle in each quadrant. So if the rotation angle is not between 0 and 360 degrees, it needs to be converted to the principal angle, and then it needs to, once you find the principal angle, then you can find out what the reference angle is. Right, so if you were at 540 degrees, you'd find out what that principal angle is, and that's the smallest angle measured, the smallest positive angle in standard position, and then you'd have to subtract that from either 360, 180, add it to 180, or 360, or 0. So as an example, if you had a rotation angle and it ended here in quadrant 2, in order to find the reference angle, you'd have to subtract it from 180 degrees. All right? So fist of 5, 1 to 5 there. Okay, good, thank you. Quadrant 1, if you had a rotation angle and it ended in quadrant 1, so you could like go all the way around. So if you had a reference angle of like 380, for example, you would go around once and then you'd go 20 degrees up. This is going to be your reference angle in this position, and you would get that by just adding your reference angle to 0. Quadrant 3, if you ended with an angle here, then you would take your reference angle by adding it to 180 degrees. Okay? And then if you have a reference angle here, you would end in quadrant 4, then you could subtract it from 360 degrees.
Isn't this exactly what we did in grade 11?
Exactly. So state the reference angles there. So if I have a reference angle of state the reference angle for each of the following rotation angles in standard position. So 195 degrees. So if this is my unit circle here, and I'm going 195 degrees around it, then this angle is going to be found in which quadrant?
The
Third quadrant. Good. Yeah, so it'll be around here. Right? So 195 degrees would go all the way around. And in order to find the reference angle, which angle am I actually looking for? Is it right here? Or is it up here?
yes.
I'll label 1 or 2. Which side am I looking for? Actually, let's put up your hands. So eyes closed. Eyes closed. Eyes closed. Eyes closed. I just want to make sure everybody understands reference angles. Okay, so if you think it's side 1 that I'm looking for, put up 1 finger. If you think I'm looking for side 2, put up 2 fingers. Okay, hands down. Good, it's side 1. So, in order to find that out, I know this is 195 degrees here. Do I add, subtract, or what do I do? Add
195 to. Oh, but you
or
subtract.
subtract from 180,
Yeah.
right? Or sorry, I subtract 180 from 195.
Yeah.
Right, so my reference angle is going to be 15 degrees.